Thank you very much. Hopefully you can hear me from there. Before I kick off, I just wanted to get a feel for the audience. If you'd be kind enough to raise your hand, I'm just going to ask three questions. How many of you are currently using renewable energy? Great, thank you. And how many of you are planning to use renewable energy? Okay, and last question, how many of you are in the renewable energy industry? Okay, got a balance of all three. What this paper focuses on is the management aspect of owning and operating a PV or a solar thermal system. And the pictures I've got actually are live sites in London with the emergency services there. And it also focuses on the use of systems to derive management information from raw data for onwards reporting for internal purposes and also for management reporting and compliance. So really a couple of simple questions here. One is, why should you determine and measure renewable yields? And what I mean by yield is how much is the asset, the generating asset, actually providing in terms of energy. And then the other question is, how do you actually determine the yields? Our company mainly focuses on commercial and industrial users of renewables, and some of the investments are a few £1,000s. We have one customer that has over 100 sources of on-site renewable, and they've spent millions of pounds. And sitting in their shoes, from a management perspective, they'd want to know, is that investment really delivering at the end of the day? And there has to be a starting point. And the starting point is really that second question, how to determine the yields. And we are not a installer of renewables. We essentially monitor them. And I've recently spoke to two major companies who do photovoltaic and solar thermal installations. And what they advised is that they essentially use similar techniques to determine what the annual yield is of the renewable energy. And the starting point and the different factors are quite complex, but as a customer, if you were investing or you want to monitor, you just need to know a couple of numbers. And what I've shown in this slide is some of the processes that the suppliers go through. So they use standardized software to put in a number of factors. In the case of PV, factors about the actual solar collector, losses, position of the roof, so on and so forth. There are a couple of types of software packages. In the case of the PV, a common one is known as PV Syst. There is also a company exhibiting here today called the Solar Design Company. And what they essentially do is take all those factors, and at the end of the day, they will give the customer two key numbers. The first one is what is the peak performance of the system, with maximum solar radiation. And the second one is what's known as the annual yield. with that information, the users then got to really try and understand whether their systems are performing. And there's some key stages. So the first one we've talked about is the understanding the yield. The second one is you've got to have an effective way of measuring the performance. The third one is monitoring. How do we go about monitoring? And at the end of the day, with monitoring, you can be really deluged with data, particularly with the multi-sites. And so how do you take that raw data and provide information to the management to make decisions about performance and where corrections need to take place? So if we start with the first one, which is the measurement. This is a site in North London, and this particular enclosure has got which is essentially the point of emergency switching. And on the left, you've got the circuit breakers, which are coming from the inverters. So the inverters are devices that take the direct current from the solar cells and convert them into energy that the grid or the building is going to accept. So those inverters feed into these enclosures, and these enclosures are the ideal location for the meter, the electricity meter, to be positioned. So this is known as an export meter, and there are many different types of export meter. And what it's essentially doing is metering the output from those inverters to the grid or to the building. The little purple box just below the meter is a remote monitoring device that takes data from the meter and sends it to a database. And in terms of meters, you essentially two types. One's called a direct current meter, and generally speaking, they're installed at the time that the PV is installed, because there's more wiring work involved to put in a direct current meter. The other option is a retrofit meter, or what they call a current transformer meter, and that's relatively trivial to fit that sort of meter. The other key fact when you're making an investment in the PV system is to talk to your supplier to try and understand what they're going to do in terms of metering. And a key requirement of meters is to make sure that there's some form of output from the meter that can either be connected to a data logger or to some kind of building management system. In the case of solar thermal, this is a photograph here of a heat meter. And what a heat meter does is it calculates the actual thermal energy that's flowing through a pipe. And there are really two components to that. The first one is the thermal flow, or the hot water. So the meter can either sit in the flow side or the return side, going back to the preheat, what they call the preheat buffer vessel. And you can either, ideally, you should monitor between the buffer vessel and the direct fired boiler if you want to actually see how much heat has been transferred into your domestic hot water system. Or if that's impractical, then you can also monitor the primary solar array side to see how much energy has been generated there. So that's the measurement part. In terms of the monitoring part, again, the key components here on the bottom is a data logger, and this data logger is connected to the meter. So it could be the heat meter or the electricity meter, and it's collecting meter readings every 30 minutes, and it's transferring those meter readings on a daily basis to the server. And with the web-based systems, you can get a whole range of information from them. So for example, if you want to get daily meter readings, you can log on and look at the daily meter readings. You can also do benchmarking. So if you have several sites, you can actually overlay one site on top of the other to see how they're performing. So you might have a couple of buildings which are in very close vicinity to each other, and you might want to ensure that the performance is similar, especially if the design is similar. And if the performance is different, then there are obviously questions to be asked. And then the other really critical piece of information is to find out whether the systems are actually running or not. I'll give you a real practical example here. In 2010, one of our customers asked us to help them with a climate change levy exemption application. So what we had to do is go and survey a number of sites for them. And we went to one of their sites, and which was not being monitored. And this was in April 2010. And we noticed that the inverters are tripped out. So we reported it back to the customer, and then about a year later, they asked us to go and remotely monitor the particular site, which we did. And when we went there a year later to do the installation, the meter readings were still the same. So they actually lost the entire summer because they didn't know. There was too much going on. The individuals occupying the building didn't really have a relationship with that PV system, because that's how it was. So that's the kind of information that can be derived. But the other thing to be aware of with this sort of systems is they can really bombard you with data. And we've had a couple of customers. One of them actually said, whoa, just hold on. What we want now is management information. This was about a year back. And so what we had to do was to analyze the data for them, but give them a really simple report, which if we look in the far right column, this particular one is showing a number of PV sites that we are monitoring. And what we actually produced for them was a traffic light system. So, when they're looking at the report, it draws their eye to the problem areas. And a big challenge was trying to determine what the criteria for the traffic lights was in terms of what is the acceptable yield. So what I did is we looked at the design documentation of the supplier, which gave the annual yield. And then we looked at the monthly yield, and we noticed that a lot of the sites were not reaching the design capacity. And then when you talk to the supplier, the what-ifs then come into the equation. What was the weather like in April? What was the weather like in March? So I think what you have to be conscious about is just because there is specific information about design capacity, that may not necessarily relate to what you're seeing. And what I've shown is the detail of the report, and our customer actually gets an executive summary, which basically tells them where to target their maintenance regime. And they use the report to provide it to their maintenance contractor, to go and follow up. But also, you can't just work on the traffic light system. You also have to have the human element there to actually analyze the trends over the previous 3 months, weather patterns, and so on. Because what you don't want is effectively a spreadsheet going and creating some sort of panic. So it's really important not only to have the systems, but the ability and the resources to look at the data that's coming from them. This is one particular PV system which I was talking about a little earlier. So you can see the flat line in the run-up up to around July 2011. And that's the PV system that had not been running for over a year. Then you can see things improve. The fault wasn't properly corrected by the maintenance people there. And with this one, the reason this PV was not running, there was a circuit breaker and a combined heat and power unit, and the PV were feeding the circuit breaker. And when they both came on, the circuit breaker wasn't man enough to cope and tripped out. PV system was great, really good design, but the circuit breaker was underrated. So these are the kind of things to be aware of. This is a solar thermal system. And this particular one can really produce quite a bit of energy. In fact, we had to use a meter that was in megawatts, purely because of the pipe dimensions. And the reason there's that flat line in the middle of November is at this particular site, the person or the manager who occupies that building was not getting enough pressure, water pressure, on the top story of the building, and so they decided to shut off or bypass the solar thermal system. So these are the kind of things we pick up, and as a result of this, the customer is going to resolve the pressure issue. So these systems can be sabotaged, not by blatant bad behavior, but just kind of work practices. So just something to be aware of. And just to close off now, what I've talked about is the importance of determining the yield, proper asset management, and the most important thing is corrective action, and actually getting your supplier, your installer involved, and maintaining that marriage with them after the installation to really make sure your assets are delivering. So thanks very much for listening, and happy to receive questions.